Before we get into the reference frame schemata, I'd like to review the material we went over briefly. Remember, with Existics, we're using a model based on the interaction of observers or observers with objects or objects within an infinite series of relative frames of reference that are interlaced into a complex system of relative frames of reference versus the model with it versus using the concept of absolute space, whereby one relies on having a limit to the number of relative frames of reference such that there is a backdrop or ultimate frame of reference from which all other frames of reference are within. So, what we have is, remember, B was the younger individual, the teenager, A was the older individual, the grandparent. In B's objective frame of reference and subjective frame of reference, time goes by slower than it does for A. And because of this, the dilemma is over a period of time, how do you account for the older person who we're assuming, since time goes by faster as we get older, that their experience of the rate of the passage of time is faster than B's experience? Then what appears to be the solution is that there's actually two events or two conversations, if you will, occurring, one relative to B, one relative to A. This conversation or event is occurring at a slower rate of time than this one, and so basically what the Existics equations are is assuming that we're dealing with a physics model along the lines of Gottfried Leibniz's interactionism, using these infinite frames of reference and taking advantage of what to some is a dilemma, that being, how do you deal with an infinite series of relative frames of reference not leading to infinity and thereby ultimately just making all of your values infinite so that your mathematics is meaningless. Basically, what we're going to attempt to do is see if we can derive a mathematics that handles that and allows us to deal with infinite progression and regression of relative frames of reference and still be within a finite context whereby we can use this model, as opposed to mathematics that comes from a model using absolute space, a finite number of relative frames of reference. And let me state that though modern physics models don't necessarily have absolute space as part of the model, the calculus and mathematics that is still used does have absolute space as an assumption. So, ironically, even though they may not be using the concept of absolute space, the mathematics that they're using does. The assumptions are still there. So we have to basically see if we can get around the issue here, and I'll go ahead and just illustrate it. And that would be that if for instance, I'm in a frame of reference, you could look at me on your screen in that little box and be like, okay, that's this room. Here I am with all the occupants in that room as in a single frame of reference. And then all the rooms in this building collectively as the building, you could see that as the next frame of reference. And then another, like as maybe the city I'm in, or okay, planet Earth, and then our solar system, and you just keep going. So the question is, well, how far do you go? And what the argument between Leibniz and Newton boiled down to is Leibniz saw no problem having having an infinite series of relative frames of reference, basing the mechanics of physics on the interactions of objects within an infinite series of frames of reference, as opposed to a finite series of frames of reference and objects existing within that in a finite series of frames of reference. And again, the assumed problem is that if you allow for an infinite series of frames of reference, all of your mathematics will blow up and go to infinity and basically be meaningless. Again, just to also go back to the infinite frames of reference, what we have here is this is B relative to B, B's subjective frame of reference, and this is A relative to B. So this would be the, since A experiences a faster rate of the passage of time, there has to exist an A relative to B such that this A is coexisting with B. And vice versa, there has to be a B relative to A such that it's coexisting in the same rate of the passage of time. So B relative to B and B relative to A, they are not coexisting. They're mutually exclusive. They're not having the same passage of the rate of time. And same thing with A relative to A and A relative to B. But this is going to also hold true for A relative to B and B relative to A if you follow it through, that we're going to end up having to have things like A relative to B, relative to A, relative to B, etc., and B relative to A, relative to B, relative to A, etc. And so basically, how do we transnumerate this, I guess you could say, or transdelineate this from these B relative to A relative to B, infinite series of relative frames of reference into a form of mathematics where we can actually quantify this, where, for instance, in our previous example, there was a 1 to 5 relationship between A and B, or B and A, I'm sorry, and for instance, for every 1 minute that B experienced, A experienced 5, or for every 0.2, let me make that a little clearer. For every 0.2 minutes B experienced, A experienced 1 minute. And again, that was A over B equals N, and B over A equals U. So these ratios here don't account for, they account for A and B being in, having a variance in time where their relative frames of reference are shifted such that they're not coexisting at the same time relative to one another or in the same present or period, but rather we have to modify these to account for that shift, which has a shift within a shift within a shift because of the infinite frames of reference going back and forth. Make that a little bit more easy to illustrate. Think about when you have mirrors and you put them together and you see that infinite, well, not infinite, but that seemingly endless series of reflections going back and forth. But the idea is that that's what's going on with these relative frames of reference, that if we could look at them from a sort of orthogonal perspective, that this is what we would see on both sides, progressing and regressing infinitely. So how do we account for all of those all of those, not just these two frames of reference, but the implied infinite series, which over here is nightmare infinity. So is it is it still a nightmare, or can we actually do something with it? I want to go back to, real quickly, the concept of objective and subjective frame of reference, that being that objects or things that we associate with the objective frame of reference are physical in nature, and that things that we associate with the subjective frame of reference are non-physical in nature. And that's not to dismiss the philosophical problem, if you will, of that no matter what objects you observe, they're going to have some form of physicality or non-physicality. For instance, I could take the most solid object here that's super dense, and if you looked at it on the subatomic scale, it's mostly empty space, which you would think is nothing, but then the more they probe empty space, they find it's full of energy. So there's this continual flipping around back and forth relationship between physical and non-physical, which really Existics is an attempt to capture that and try to do something with it mathematically, so that to see if that somehow adds to the qualitative understanding of physics. Also, to emphasize here that yes, we are applying the concept of extension with non-physical by giving dimensionality to subjective frames of reference, which would seem somewhat contradictory. However, the point of that is to be able to mathematically put physical and non-physical things more or less perpendicular or orthogonal, however you'd like to think of that, so that we have a dimensionality to these, because what you will find is that as we progress by doing this, whether you want to believe in non-physical, whether you think this is some kind of spooky spiritualism type thing, the reality is that with the added dimension mathematically, it really appears that some solutions arise. So do with it what you will. You may personally want to even define this as something completely different. So really what we're looking at here is sort of an interweaving, orthogonal interweaving, a complex not manifold, but not quite a surface of objective and physical and non-physical, objective, subjective, relative frames of reference that are interwoven, that infinitely progress and regress in their interconnectedness. So we're fully embracing the implied problem of infinity that the concept of absolute space was an attempt to solve. We're embracing the problem and seeing if we just go straight ahead, and just face it, if maybe somehow we can find a solution to it without having to rely on a concept of absolute space. And even though it's been abandoned for the most part, it's still within the mathematics. So we kind of do need to go back to the old calculus and modify it. As kind of strange as it is that we haven't. So anyway, trying to think if there's anything else real quick to pull out of this before we move on. And I guess that's pretty much it. I cover this in a little bit more depth on the Existics 101 website in the series titled Existics 101 Postulates Part 1 through, I believe, 6, and then Relative Frames of Reference Parts 1 and 2. I apologize for the rendering problem of everything progressively changing to the color green, but it's what we have for now. So now we'll go ahead and move on to to deriving the mathematics. Now that we have a little bit of an understanding of how these infinite relative frames of reference interweave and work together, let's go ahead and see if we can sort of lay them out in a schema so that we can really have an idea of where we might want to start to get a form of mathematics that can account for this. So, start off with defining A in terms of relative frames of reference. A exists as A relative to A, and A relative to B. If you recall in the postulates of Existics, B is essentially part of the definition of A because for something to exist, it must be in an interaction with some other thing that exists. Therefore, there are at least two things, and those two things, those minimum two things, are going to be A and B. And therefore, B is going to be essential to the definition of A in terms of an infinite series of relative frames of reference that are interwoven or interlaced, however we're going to describe that. A relative to A has the components of A's reference of A. I'm going to use this sideways triangle that goes like this, sort of represent a reference frame. So A's reference of A relative to A. You could sort of think of A's reference of A relative to A, this subjective frame of reference of non-physicality, if you will. You could think of it as an iteration of self-reference. Sort of the way I like to think of it. And then we have that A relative to A is composed of B's reference of A relative to A. Now the reason why we have B's reference of A as part of A relative to A's definition versus A's reference of B is quite simple. That is, for me to exist relative to you, you have to be observing me. So this camera on your behalf is making reference of me. Therefore, in this form, I exist in your frame of reference relative to you. So that's why it's essential that for A's definition, B's reference of A relative to A is part of it. A relative to B consists of A's reference of A relative to B and B's reference of A relative to B. So here you can see A and B's relationship starting to become entangled, such that in order to define A, we have to ultimately now define B. So we'll go ahead and do that. It's more or less the same. B exists as B exists as B relative to B and B relative to A. The components of B are B's reference of B relative to B, A's reference of B relative to B, B's reference of B relative to A, and A's reference of B relative to A. So, and then of course, going back to what we discussed earlier, these are just going to run off into infinity as just branches and branches, infinite relative frames of reference and all possible combinations that we could ever come up with. And so what we could think of is let's take this orange marker and look at that as A, and this blue marker and look at it as B. We'll put the blue marker down for a minute. The reason why I picked the orange and the blue one I think should be obvious, that being that these are complementary colors. So they're sort of codependent on each other's existence, and ignoring the other colors for a moment, if we were to take these two and bring them perfectly together, we would get white. So you could see that as a over as n times u equaling 1. So this is sort of the analogy to make this schema a little more intuitive. So we could see that A breaks down into A relative to A and A relative to B, and then these would continue to just break down further and further. And whether or not it goes infinitely as far as this marker is concerned, that becomes an issue of debate. But as far as the reference frame schemata, this just keeps going infinitely for both of them. Something to notice is that A's reference of A, which is a subjective frame of reference, and relative to A, and A's reference of A relative to B is also a subjective frame of reference, and these are both more or less the subjective frames of reference that have to do with the complete existence of A, both relative to A and some other. We can denote these as being collectively the subjective frame of reference for A, and likewise these two can be the collective objective frames of reference of A. And same thing for B. And so though we haven't necessarily come up with a mathematics yet, it's becoming apparent that this problem of the infinite, what for A will be a progression and what for B will be a regression, that this infinite series of relative frames of reference should be able to be handled in the sense that we can categorize these infinite frames of reference and put them into specific sets or groups. So we would have, the collective subjective frames of reference, the collective objective frames of reference, and it would be, so these are categories just as A and B are a form of category. So we sort of are going from a category to a category with a issue of infinite frames of reference in the middle. This becomes a continuum issue, very similar to the real number line. So though I haven't necessarily at this point accounted for how we're going to handle this and not have our mathematics running off into infinite numbers that ultimately destroy our values, it looks like it's going to be promising. So another thing is, let's go back to the pens, the markers. So we've got A and B together. Well, let's say I bought them together and they were in a package. So I bought a single pair of markers. Okay, well we can look at these collectively as a single thing. So another way these relative frames of reference come back together is that we could take the collective subjective frames of reference and the collective we could take the collective subjective frames of reference of A and the collective subjective frames of reference of B and bring those together. And that's just subjective frames of reference. We could also take the collective objective frames of reference of A and the collective collective objective frames of reference of B, bring those together, and that's a collective objective, and thus this implies the existence of a greater thing, namely, greater A or bigger A, however we're going to call that. So A and B, through their intermingled infinite series of relative frames of references that are infinitely progressing and infinitely regressing, they come together through an interesting way of ordering, and ultimately can pop out as just being a pair, a single entity in and of itself, which of course must be in an interaction with some other thing, that being some hypothetical greater B. And of course the same would apply to B, and what this automatically implies is that the same also applies to A and B, likewise, and that there's ultimately little a and little b, and something going on here also for B, and that, and this just keeps going. So what we really have is this completely interconnected branching of infinite relative frames of reference that mingle, commingle. They themselves split up and can be broken down into sublet frames of reference, or grouped or branch out in their natural progression and brought together in collective orders and form larger objects that also imply the existence of other things. So this really is just a giant like fractal, or I don't know what you want to call it, but this is more or less the reference frame schemata. So even though this thing itself just keeps getting infinite more and more in all these different possible ways, we're still having series of specific categories where obviously we can say, okay, these are collectively groups of these, which are collectively groups of those, and so on. So this is our reference frame schemata, and again, the branching tends to go towards basically four main ordering types. And even though we can imagine, A relative to A relative to A relative to B, and all these different kinds of strange configurations, ultimately the ones that are of concern, because the others appear to ultimately just cancel each other out as far as their significance in accounting for them in the mathematics, sort of like in linear algebra dealing with matrices and the use of diagonals and stuff like that. So what we ultimately have is that the ones that are of concern are A relative to B, relative to A, relative to B, ad infinitum, alternating, and then it's reciprocal B relative to A, relative to B, relative to A, so on. And this thing relative to A, or relative to B, and this thing relative to A, or relative to B. So it's going to be in here where, now that we have an understanding of how these things go together, which ones are of significance, now we'll be able to derive a mathematics that can replace what we were using before, that being A over B equaling N, and B over A equaling u n times u equaling 1, that where this does not account for the infinite series of relative frames of reference progressing and regressing, now that we've laid it out in a schematic and we see which ones are of more importance for our purposes, deriving the mathematics is now possible.